A penalty kick can reach the goal in less than a second. If a goalkeeper waits to see where the ball is going before reacting, it's already too late. Yet the world's best goalkeepers still make incredible saves. How? And penalties aren't the only mystery. Perfect passes, bending free kicks, and impossible goals happen in almost every match. They may look like magic, but they're actually governed by the same mathematics and physics you learn in school. Let's explore the science behind football's most amazing moments. The first challenge in football is finding a way past defenders. Imagine you're a midfielder. Your teammate is sprinting towards the goal while defenders are constantly moving to block every possible pass. A passing lane that exists 1 second can disappear the next. Finding the right pass isn't just about vision. It's a problem of geometry. Players constantly judge angles, distances, and the positions of everyone on the pitch to find the safest path for the ball. Even a small movement by a defender can block one passing angle while opening another. This is also why football teams often form triangles. When 3 players position themselves like the corners of a triangle, the player with the ball has multiple passing angles instead of just one. If one passing lane is blocked, another is often available. This simple geometric shape helps teams keep possession and move the ball more effectively. But finding an open teammate is only the first challenge. The next is getting the ball to exactly the right place. Whether it's a short pass, a long ball, or a cross into the penalty box, the ball has to travel the right distance, avoid defenders, and arrive at the right time. The moment the ball leaves a player's foot, the player loses control. From then on, physics takes over. The force of the kick determines how fast the ball travels, while the angle of the kick determines how it begins its journey. At the same time, gravity starts pulling the ball downward, making it follow a curved path called a trajectory. This type of motion is known as projectile motion. You've probably seen the same thing when throwing a ball. Throw it almost straight up and it goes high but not very far. Throw it too low and it may never reach the target. Every football pass is a physics problem. A player has to choose the right combination of force and angle so the ball reaches a teammate before the defenders do. A low pass travels quickly but can easily be intercepted. A lofted pass can fly over defenders, but because it stays in the air longer, opponents have more time to react. Every successful pass is a careful balance of force, angle, distance, gravity, and timing. Sometimes, though, a straight path isn't the best one. Imagine a defender standing directly between the ball and the goal. Instead of kicking through them, players can make the ball bend around them by striking it off-center, causing it to spin. As the spinning ball moves through the air, one side moves with the airflow, while the other moves against it. This creates a difference in air pressure around the ball. The higher pressure pushes the ball toward the lower pressure side, making it curve through the air. This phenomenon is called the Magnus Effect. That's why a free kick can appear to be heading wide before suddenly curling into the top corner. We've explained the Magnus Effect in much greater detail in another video, so be sure to check the link in the description. Football isn't just about controlling the ball. It's also about making the best decision in a fraction of a second. Imagine an attacker near the penalty area. They could take a difficult shot from a narrow angle or pass to a teammate in a much better position. Both options are possible, but one usually has a higher chance of leading to a goal. This is probability. Professional footballers don't calculate probabilities during a match, but after years of training and experience, they instinctively recognize which decisions are more likely to succeed. Goalkeepers use the same idea during penalties. Before matches, they study where different players usually place their penalty kicks. Some often aim to the left, others prefer the right, while some frequently shoot down the middle. These patterns cannot predict every shot, but they increase the goalkeeper's chances of diving in the right direction. Probability doesn't guarantee success. It simply helps players make smarter decisions. Mathematics also helps teams away from the football pitch. Modern football clubs collect enormous amounts of data from every match, including passes, shots, player movements, running distances, and ball possession. Using statistics and artificial intelligence, analysts identify patterns that are almost impossible to notice during live play. These insights help coaches improve tactics, manage player fitness, prepare for future opponents. So the next time you watch a football match, remember that every accurate pass, bending free kick, spectacular save, and tactical decision follows the laws of mathematics and physics. But footballers aren't solving equations while they play. Years of relentless practice train their brains and bodies to judge angles, speed, force, timing, and space almost instinctively. Science helps us understand why these incredible moments happen, but it is the player's skill, dedication, and thousands of hours of practice that make them possible. Mathematics and physics explain the game. The players are the ones who bring it to life. If you enjoyed this video, please like and subscribe to Just Learning, and tell us in the comments which team you're supporting in the FIFA World Cup 2026.